In previous video, we have seen how to construct the linear regression model using trained dataset and how to evaluate the performance of the linear regression model using test dataset. So we have splitted the original dataset into train and test. The model is built using trained dataset and it has been evaluated using test dataset. So we have predicted the result of test dataset using the build machine learning model. Okay. Now in this video we are going to see how to plot the graph for the train mean square error. Okay, so what I did here in this line is I have created a data frame called actual underscore train data, which actually consists of the labor hour column and the labor cost column from the train dataset, from this dataset, which has 1310 observations. So let's run this line. So this actual train data frame it is created, which has these two columns LH and LC. Then we'll try to build the linear model. So when we are building the linear model, in formula we have considered only one variable, that is we want to calculate the labor cost using the labor R column, and the data set that we have passed is the actual underscore TR data. So this data frame has been passed. So let's run this model. So we have our train linear regression model in this object called tr underscore model underscore lm. So this is optional thing, that is if you want to plot this model, then you can plot it on the graph. Okay, I'll just skip this line because we have seen how to plot the linear regression model using the plot command, okay, in the previous video. Now my objective here is to predict the result for the train data set and then find out what is the error for the prediction of the model. Okay, we usually calculate the error as the actual minus predicted. So what our model has predicted minus what is the actual value of the given instances, so that would gives us the error. So here I have used the function called predict. Okay, to this predict function I have passed my model. So my model here, it is in this object tr underscore model underscore lm, comma, and this actual tr data, this is the data frame which actually have the actual values for the labor cost. Okay, so we'll just run this. Okay, fine. Now we'll see the result of first 6 instances, the result of prediction. So this is the result of predictions. So my model has predicted the labor cost for the first train instance is $78.75. Then for the second instance it is $308.60, and then for third it is $71.34, and so on and so forth. I have just displayed here first 6 instances, but we have total 1310 instances, 1310 observation in the actual data frame, whereas in the train data set we have the same number of instances. Okay, so now we'll try to find out the error that model has made. Okay, and I have just mentioned how to find out the error. So error is calculated as the difference between the actual values minus predicted values of your model. So this is the formula we have used to find out the error. So I have indicated the error with the object called difference, and LC underscore pred underscore train, which has the predicted values by our model for all the 1310 instances, minus the actual value of labor cost column from this data frame called actual underscore tr data. So we'll just run this line. Okay, now we'll see what error is found for the first 6 instances out of this 1310 instances. Okay, so this is the error made for the first instance. The error value is 12.45, whereas the error value for the second data point is minus 16.47, and that too for the third instance is 4.70, and so on. So here we have calculated the error for all the instances. So we have total 1310 1310 samples, 1310 instances in the data frame called actual underscore tr data. Okay, and in the same way we have we have also the 1310 values in the tr data object. Okay, so we'll plot this difference. So this plot will give you the error for all the 1310 data instances or data points. Okay, fine. Now we know that our objective is to plot the mean square error for the trained data set. So we'll find out the mean square error. We know what is the formula to find out the mean square error. So the formula is square root of the error made for all the points, right? So this is the formula we have used, square root mean and the difference object in which we have the error for all the 1310 instances. Okay, so let's run this line and let's see what value has this object MSE. So the mean square error for the trained data set is 49.88. We can also plot this mean square error for the trained data set. So this is the plot for the mean square error. So this value will give you the answer 49.880. In the same way, we can also plot the graph for the test mean square error also. So again, I will copy this values of this LH column and LC column from the test data set, okay, to the data frame called actual underscore test data set. Okay, so that means this frame has two columns which is called as LH and LC. So this LH and LC column, it has the values of test data set instances. Okay, now again I'll run this line. Okay, because we have selected this portion, so that's why it gives the error. Okay, then we'll also create the linear model for this data set by using only one variable. So in formula we are using only one variable, that is labor hours, to calculate the labor cost. Because in the previous video we have seen the labor cost, the labor hour variable, it has the major confidence in building the machine learning model. So this time we have selected only one variable, one that is labor hour, which has the highest confidence. Let's run this. Okay, so this is optional line. If you want to plot the graph for this linear model, then you can plot. I'll skip this line. We can also create the term plot for this model. So term plot is, it actually plots the regression terms on the x and y axis. So that is the use of term plot command. So again we'll predict the result for this actual test data set frame, in which we have copied this two column labor hour and labor cost. Okay, so for this prediction we have given the parameter that our linear model for test data set and then the actual test data set, and we have predicted the predicted values. They have been stored in this object called LC underscore pred underscore test. So let's explore the first 6 instances prediction of our model. Okay, so our model has predicted the first 6 instances as the for first variable the labor cost is predicted by model is $181.17. That too for the second instance it is $61.58. For the third instance the model has predicted the labor cost $258.56 and so on. Okay, now to plot the mean square error for the test data set, we first calculate the error. So to calculate the test data error, we have defined this formula, that is difference is the object which indicates the error for the test data, and the formula is the prediction of our model for the test data minus the actual values of test data for the LC column. Okay, so let's run this. Okay, and we'll see the error for the first 6 instances. So the error for the first instance made by the model is minus 51.85, That too, for the second instance it is 17.15, for the third instance it is minus 1.72, so on and so forth. So by the time we reach to the sixth instance, the error made by our model is 1.68. So we can also plot the graph for the error. So this is the graph for the error. Okay, so this is the test error graph. Now for the train MSE, we have seen how do we find out the mean square error. In the same way, we can also find out the mean square error for the test data also. By using this line, we can find out the mean square error, and we can see what would be the result for the mean square error for test data set. So the mean square error for the test data set is 41.74. We can plot this mean square error across the x and y axis. You can zoom it. Okay. So this is how we can plot the graph for train MSE and test MSE. For plotting the graph for train MSE and test MSE, what we did is, first we have copied the labor hour column and labor cost column into some data frame. Okay, then we have built the linear regression model using that data frame. Okay, and then the predicted result by the model and the actual result of the each instances, they have been stored into the object called lc underscore paid underscore train. Okay, and then finally to calculate the error, we have used this formula, that is in this object lc underscore paid underscore train, we have the prediction of all the instances minus the actual train data's lc column. Okay, so this is all for the creating the graph for train mean square error and test mean square error. In the next video, we'll see how to apply the cross validation on linear regression model. Thank you very much.